Okay, so here's our next sample problem. These problems, once again, they're all kind of variations on a theme. They're very similar problems, okay? And once you get the pattern down, they actually end up being not too bad. They look like they're a lot because the rice table takes up a lot of space and it's big and scary, but it's actually it should make a lot of sense to you. A lot, I don't know. It should make a lot of sense to you at this point in the year. So here we have a problem where you're given the Ka, okay? And you need to determine the concentration of H3O plus from this Ka value. Now, this is a different type of problem, but we're going to go about it in a similar way, okay? And like I'd recommend for all these problems, I'd like you to write the rice table first. Okay? See if you can pause and fill out the rice table. Okay? See how far you can get. Hypochlorous acid comes from hypochlorite, which is ClO minus, so the acid would be HClO plus H2O yields H3O plus ClO minus. Good. No problem. Okay? This 0.250 molar, okay, that's our initial concentration of the solution. So that's 0.250 molar. And then my concentration of H3O plus initially is 0 molar, and ClO minus is 0 molar. I don't care at all about water. Okay? All right. And I think that's about all we can fill out for now for the rice table, right? So the next thing is I'm given a Ka and I need to find H3O plus. Well, let's write the Ka expression. Ka equals concentration of H3O plus times concentration of ClO minus all over concentration of HClO. Yeah, all right. Now, I'm given a value for this, which means I can solve for some stuff in here. I also have this initial concentration, well, I don't have an equilibrium concentration of this, and so we're going to talk about that. All right? So let's come back up to our rice table, and let's look at what's going on here. All right? I don't know how much everything's going to change, but I know that these are going to increase by some value, and it's going to be the same amount, and this is going to decrease by the same value, okay? So I could say that this was plus x, this was plus x, which would make this minus x, and then this would just be 0 molar plus x, which would just be x. This would be 0 molar plus x, which would just be x. And this is 0.250 minus x. Okay, put your pencil down and just kind of look at what happens if I try to do this, okay? So if I plug in these values down here, I get x times x, so that's x squared, over 0.250 minus x equals Ka. All right, so now I could cross multiply, and I get, here, I'm going to come up here a little bit, Ka times 0.250 minus x equals x squared. Okay, now I can just keep simplifying. Okay, I can distribute the Ka, so Ka times 0.250 minus Ka times x equals x squared. And now I can get everything on the same side. So x squared plus Kax minus Ka times 0.250 equals 0. Now, you look at this and you think to yourself, holy moly, Batman, is that a polynomial? Yes, it is. How would you solve something like that? Well, you'd have to use a quadratic equation. And how do we feel about that? probably one of these, maybe with a little tear in there. Okay, we're not really going to be solving a lot of quadratics. I might have you do it once just to prove to yourself and to your math teachers that you remember how to solve the quadratic equation. But instead, I think what we're going to go up here, what we're going to do, is we're going to use a little bit of logic to simplify. Okay? So here I'm going to, you can pick up your pencil and you can start following what I'm doing again. I am going to, I'm going to take some of this stuff down with me. Copy. And I want to bring this down. I just kind of want to restart down here. Which of course means I'm going to have to do this. Oh, no, 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 that's not, come on. Just work with me here. Work with me here, folks. All right, well, we can at the very least do this. Okay, so there's that one. Here's this one down here. I probably could have just rewritten it. Oh, come on, Mr. Ryan. Technology, stop it. All right, yeah, so I probably could have just rewritten that in the time it took me to do that. But I'm going to come back up here, okay? My Ka for this acid is 10 to the minus 8. And if I think about what that means that this reaction hugely, hugely favors the reactants, right? Which means I'm not really going to form much of the products. So this value is going to be really small, okay? And if I think about it, if I think about this polynomial, this x squared term is going to have the biggest effect on everything else, okay? So my if I think of like the square root of 10 to the minus 8, I get something in like 10 to the minus 4, okay? Now if I take 0.250 and I subtract 1 times 10 to the minus 4, to 3 sig figs what I get back is 0.250, okay? So what we're going to say is that this 0.250 minus x is just 0.250. And that's the big assumption that we're going to be making often on this chapter, okay? Especially in these problems where there's an unknown value and you end up with x's, okay? I want you to make this assumption. I might ask you, hey, is this a good assumption to make? Is it a fair assumption to make? And maybe we'll talk about that more later. Okay, so if I make that assumption, this gets much easier, okay? This becomes x squared over 0.250 times Ka. Oh, well that's easy now. X squared equals square root, oh, no, not square root yet. Well, okay, I'm gonna have to square root both sides, so I'll just skip a step. Ka, which is 3.0 times 10 to the minus 8, times this 0.250, all right? And what I get is that x equals 8.7 times 10 to the minus 5, which, if I think about it, that's the concentration of H3O+. That's what I'm looking for. Yay! And now you can prove to yourself, okay, 0.250 minus 8.7 times 10 to the minus 5 is 0.250. Hey, there you go. The assumption is fair to make. All right? So here's your second sample problem.